Today we are the group of Concilio, Fio, Layasan, Maliao, and Urbano, and we are here to apply FPGA to number 3, which is a binary counter which counts from 0 to 4 repeatedly is available. Design a minimal logic system to produce a binary sequence which is 5 times the count sequence.
So this is the output of the 0 to 4 counter. So the first output is multiplied by 5. So the output is all off. And the second output is 00101. So that's 10. And the third output is 01010. So that's 15. So the fourth output is 01111. So that's 20. So the last output is 10100. So this is the circuit diagram. So we assign A on B0 and B on B1 and C on B2.
So this is the code for our PIT, and it has the input and outputs, clock, counter, LED A, B, C, and LED 1, 2, 3, and 5. The reason there's no LED 4 is because we noticed that LED 2 and LED 4 is just the same. So it is connected to B, so we did not include it. And here we declared our inputs and outputs. Input is clock, then output is the ABC and the LEDs. Then we have this counter for the counter. Then initially, this module gets its clock signal from here, and it is instantiated here, and the inputs is the clock and the output is clock out because there is an output of clock out here, and we will assign this clock out to this clock out. And after that, initially the counter is 0 and also the LED CBA, and every positive edge of the clock, it will begin to count. And if the counter is 5, then it will reset. Then else, it will begin to increment. So after ani kay the values of CBA will be assigned to LED 1, LED 1, 2, 3, and 5. So based on our schematic or the Carnot map, LED 1 is equal to A, LED 2 is equal to B, LED 3 is equal to C or A, and LED 5 is equals to C, and LED 4 is also equal to B. And I think that's all for the code.
So as discussed by Roger, he explained the code thoroughly. So now I will explain how or giunsa na mo change sa location sa mga LED in order for it to function properly when we put it in our circuit. So our LED 1 output is located at 25 and the IO type is LV CMOS 18. So it applies to all the LED and the counter even. So our LED 2 is located at the 26th pin. So our LED 3 is located at the 27th pin, and our LED 5 is located at the 28th pin. So don't mind this A or B or C. I believe Lex Ernest will discuss how those function through a circuit diagram.
In conclusion, our project is good for demonstration purposes because, as you can see, it is still on a breadboard. But if you would like to develop it further, you may implement it on a PCB or even replace the LEDs with a 7-segment display for the outputs. That would be all. Thank you so much.